If a shark bites through the internet cable at the bottom of the ocean, how is it repaired? And more importantly, how do we determine where exactly the cable is damaged in the vast expanse of the ocean? The entire traffic on YouTube and countless other internet services travels through hidden undersea cables. This underwater highway is something we use daily but can never see. The network of undersea cables is so extensive that it connects all the continents. These cables are laid at depths of up to 8,000 meters, where the pressure is around 5,300 kilograms per square inch. That's equivalent to putting the weight of an African elephant on the smallest toe of a human foot. Under such extreme pressure, the smallest segment of an undersea cable runs under the Black Sea, connecting Azerbaijan and Turkmenistan, stretching around 300 kilometers. The largest segment is approximately 6,600 kilometers long and is called the Maria Cable, running from Virginia Beach in the United States through the dark depths of the Atlantic Ocean, ending in Bilbao, Spain. In total, the length of all the undersea cables laid across the world's oceans exceeds 1.4 million kilometers. That's enough to wrap around all the planets and their moons in our solar system and still have enough cable left to circle the Earth once more. Laying cables at such depths isn't a simple task. Laying just 1 kilometer of submarine cable can cost up to $2.5 million. Now, imagine the cost of laying cables that stretch over 1.4 million kilometers. Why is all this necessary when, in today's world, satellites could provide wireless connectivity globally? The truth is that there are 493 submarine cables worldwide, each capable of handling 4,000 terabits of data per second. To put it simply, one cable can stream 4K movies for 80 million people simultaneously. In contrast, a satellite could only allow around 24,000 people to watch a 4K movie at the same time. To meet global demand, more satellites would be required, which would be costly to install and maintain compared to submarine cables. Moreover, if a satellite encounters a major fault, replacing it could cost around $400 million. That's why, despite the challenges, laying undersea cables remains easier than relying solely on satellite or wireless connectivity. This undersea highway constantly carries billions of gigabytes of data. You might think that such a vital infrastructure must involve thick, heavy cables. However, these cables, typically yellow and black, are only as thick as a garden hose. Surprisingly, the actual fiber optic cable inside is as thin as a human hair. How does so much data pass through such a tiny wire? This hair-thin wire is the fiber optic core, made of glass or plastic, which transmits light-carrying data in small packets. First, the data from a computer is converted into light signals using a transmitter, which does this through laser light or LEDs. These light signals are transmitted as pulses, representing binary ones and zeros. A light pulse indicates a 1, and the absence of a pulse indicates a 0. The core transports these pulses surrounded by a cladding layer that keeps the light from escaping and instead reflects it back into the core. This process is called total internal reflection. As the light signal weakens over long distances, repeaters are installed every 100 kilometers to boost it. A DC current of 100,000 volts is sent through the core and cladding, powering these amplifiers because there is no power source in the middle of the ocean. The fiber optic cable can also transmit multiple signals simultaneously using a technique called wavelength division multiplexing, WDM, which passes light of different colors through the same fiber, each carrying different data packets. Light travels at a speed of 299,792 kilometers per second, meaning data reaches its destination almost instantly. Once the data reaches its destination, a photodiode or photodetector converts the light signals back into electrical signals, which are then reconstructed into graphics or other forms by a computer or mobile device. Despite being robust, these cables are susceptible to damage from earthquakes, shark attacks, and underwater volcanic eruptions. However, the most common cause of submarine cable damage is fishing activities. Some vessels use trawl nets that are dragged along the ocean floor, and if these nets accidentally snag a submarine cable, the cable can be severely damaged. The question arises, if a cable gets damaged in such a vast ocean, how is it repaired? And how do they determine the exact location of the break over thousands of kilometers of cable? Modern submarine cables are about an inch thick, and 1 kilometer of cable weighs approximately 1,400 kilos, as much as a sedan car. These cables are laid in one continuous piece on the ocean floor using special ships. After extensive research, a specific area is chosen, and large rolls of cable are loaded onto the ship and transported to the location. A robotic machine capable of moving along the ocean floor is used to dig a trench about 1 meter deep, where the cable is laid carefully. Installing these cables is a slow and meticulous process. For example, laying the 6,600-kilometer cable between the US and Europe took nearly 2 years. When one ship's cable roll is depleted, another ship takes over, connecting its cable to the existing one, and the process continues. Weather is the biggest obstacle in this operation, especially in the Atlantic Ocean, which is frequently hit by hurricanes and strong winds. Installation is often paused until the weather clears. Given the challenges of installation, imagine how difficult it must be to repair a cable. Data centers at both ends of the cable monitor its activity 24/7. If the connection is lost, it means the cable has been damaged somewhere in the ocean. To locate the exact point of damage, a device called an optical time domain reflectometer, OTDR, is used. This device sends a light pulse from both ends of the cable. Since the cable is broken, the pulse bounces back. The time it takes for the pulse to return and the strength of the signal helps estimate the distance to the breakage. The process is done from both ends to verify the location. Once the damaged location is confirmed, the DC current is cut off, and remotely operated vehicles, ROVs, are sent to the ocean floor. These ROVs inspect the cable physically and then lift the damaged portion to the surface for repair. The damaged section is cut out and replaced with a new piece. Since the fiber optic core is made of glass, it's crucial to join the glass pieces seamlessly, a process known as splicing. If additional cable is needed or the ocean floor is particularly deep, extra wire is added before laying it back down. The benefits, functioning, installation, and repair of submarine fiber optic cables should have answered many of your questions. We hope you enjoyed this video and would appreciate your likes and shares. Thank you for your kind comments, and we'll see you in our next exciting video.